Okay, this is the spreadsheet, guys, for your tutorial groups. Right. Now, if you just scroll down, I don't know what this mouse is lagging. If you scroll down, you're supposed to see your name if you were supposed to be on QSD. You getting it? This is the group for all the QSD attendants. You getting it? Yes. This is just QSD. And then if you want Wednesday, you're supposed to be here. You just look for Wednesday down here. Are you getting it? And then you just click Q Wednesday. Is it Wednesday or Wednesday? I don't know. But it is what's supposed to be. Not wedding. Wednesday. So you're supposed to see your name there. Apparently all of you are located here. So you can just keep scrolling, you will be able to find your name. If you are on this day, just go and click on this day and then you're supposed to see your name. You getting it? I am 99% sure that your name is here. If it is not here, then there is something that is wrong, but it's supposed to be here. Look at it for now. If you missed your TAT yesterday, just try and find a slot, maybe for today's TAT, go and attend, or tomorrow. You getting it? Yes. Just to make sure that you don't miss the TAT, go to today's tutorial and tomorrow's tutorial, or tomorrow's tutorial. You get it? And tomorrow at 7 up to 9. Are we writing a test? Okay. Tomorrow, starting tomorrow. So it's Thursday and Saturday. There's an ATP, an extra class. So you attend for the whole 2 hours from 7 up to 9. If you can make yes PM. Yeah. 7 up to 9. If you feel like I still don't understand this factorization thing, this domain thing, which is easy, you have to attend. You have to attend. Well, yeah, it will be communicated on Are You Connected? Don't worry. All of you will know. Now, are you happy so far with that? I want all of you to get distinctions, guys. You have tutorials, you have ATPs, you have consultation, there is everything. So that you can see what is your plan, so that we don't disturb you from your plan. Yes, that's it. I think that's all I wanted to say, ATP and the tutorials. If you still can't find your name, you're still welcome to talk to me, then we can check. You getting it? I don't want you to fail because of you can't press some few buttons, or we made a mistake on our side. Are you getting it? Yes. Now, let's go to the topic of the day. 10 minutes has elapsed. Don't know, this network was giving me issues. I'm trying now to make sure that this we can go and do something as quickly as we can. Yesterday I had a meeting. It took longer than I expected. So I didn't get a chance to actually check do your homework and upload it, the solutions of your homework, but I will do it by the end of today. You getting it? Yeah, we had a homework. We did have a nice homework for a domain. I will upload it on Are You Connected, and maybe the explanation will be on our channel. You getting it? Yeah, if you want not to miss something, it's not compulsory. You can subscribe so that every time I post something, I didn't get a chance to post yesterday's lesson, but it's there, I recorded it. You can just press the subscribe button. Don't have to worry. After some time, we'll delete that thing. When we're done, all of us have passed, so that everyone will always start on the same slate in this class. Now, I want us to talk about something that is very much important. These are my consultation times. This is not the one. We're not doing domain today. We're done with the domain. We'll revisit it again when we're doing the range. You know how to find range, right? Yes, range is not that hard, guys. When you are finding the range, all you just do, we're not going to do it today, we'll do it later, but I'm just giving you the trick here. If you want to find your range, first thing, if I give you a function and say find the range of this function, you just find an inverse of that function. The domain of the inverse will be the range of the original function. And the range of the original function is supposed to be the domain of the inverse. So if you know how to find a domain, then that's good. You'll be able to find a range. It's not that deep. You know what is the domain? Set of input values that is making the function defined. And if you know that I'm trying to find this, you can just look at the opposite. You just be like, okay, what are the values of x that are making this function undefined? And then you just say, okay, these are the values of x that are making this function undefined. Okay, I don't want that. And then it will be easy for you to deduce the domain. But today, I want us to talk about symmetry. Today and tomorrow is all about the shapes of a curve, right? What do we mean when we say a graph has even symmetry, right? You have something to say, thank you. Can be cut into two equal parts. Thank you. Anyone who has something else to say? So she is saying that if I have a graph of this kind, what is this thing? I don't like it. Yeah, so this is y, this is x. So if you have a nice curve of this kind, this one I can cut it here, somewhere here, and then I get equal parts. Is that what you're saying, right? She's saying that this have even symmetry if you can cut it like this. Anyone else who have a different view? This is not my thing, you guys. Also, it's not your thing, it's an us thing. You getting it? Not our thing, it's an us thing. Yeah, so you contribute and contribute. If I am wrong, you correct me. This is our thing. Not our thing, actually, an us thing. Our thing is for other departments. Here is an us thing. I don't want anyone to say, this guy's English is bad. No, it's a math thing. If I have to teach language, then maybe things will be different. Now, what do we mean by saying a function has even symmetry? I will give you a picture of what I mean and also give you a mathematical representation. Right. If let's say I have some function y is equal to f of x, right? If let's say now I take the value of minus x, the opposite of that, and I plug it inside, I am still getting f of x. You getting it? Even if I take a negative value, I plug it in the function, I still get the same value as that of the positive value. You getting it? That's the meaning of this thing. For instance, suppose that I am saying you have your f of x is equal to x squared. You get it? Now, if let's say now I want to find f of minus x, at the place of x, I'm plugging minus x. So here I will have minus x squared. What is minus x squared? So it is x squared. And if you look at this x squared, it is the same as f of x. So I am still getting the original function. Do you get it? You don't get it? Yes. Okay. Thank you. I'll get paid next week. So I have to explain. I have to keep explaining. Don't worry about it. You're going to pay your fees either way. It's not like I'm doing you a favor. No. We're in a partnership here. I give you something, you give me something. On the 25th, I don't negotiate. I want my money. So it's up to you if you don't want your part. I don't give a damn. If you don't want it, I know that your plan is to explore. So I'm saying, if this has even symmetry, right? Even symmetry means that I take the negative value, I plug it inside, or the opposite, right? If I plug it inside, I still get f of x. That's what I mean. You get up to this part. Where was the person? I can't see you. Okay, thank you. So I'm saying if I give you a function, I'm making an example of I have f of x is equal to x squared. And the question is does this function have even symmetry? Yes or no? How do you test it? To test it, you plug in minus x in the value of x. You getting it? Yes. So here, I wanted to check minus x. What is the value of minus x? The original function was f of x is equal to x squared. So where there is x, I'm going to plug in minus x and then I square it up. Right. Minus x is the same as minus 1 times x to the power squared. And then when you have that nice thing, you can see that this is minus 1 squared times x squared. You can see that these are laws of exponents. And what is minus 1 squared? What is x squared? X squared. So when you multiply the two, you will end up having x squared. Are you getting up to this one? Now, if you look at this x squared and look at the original function, is this x squared not the same as f of x? Yes, if that is the case, we say that this function have even symmetry. Do you get it up to this part? That's what I said, guys. You don't have to go to the water or the mountain to figure this out. We can figure it out here. There are serious things that can make you go to the mountain. Go for those serious things. Not this. Okay. Now that we have this out of the way, I talk about the function. If I give you a curve, how will you know that this curve is that of an even symmetry function? How will you know? This is what is supposed to happen. And you have to take note of this. You have an x, you have a y. If a function have even symmetry, I have some x here, right? Right? Now, the output is supposed to be somewhere there. Okay, the output is supposed to be somewhere there for this x. If I pick a minus x this side, the output is supposed to be the same output as that of x. That's the meaning of that. So we're supposed to have some output there. What is going on with this thing? Yes, we're supposed to have an output there. So whether I take a negative, I take a positive or a negative, I'm supposed to get the same output. You getting it? So an example, we said if we have x squared, right? X squared is of this shape, right? Now, if I take a value here, x is here, I'm supposed to have the same value but with the negative input. That's what is happening with the picture. In other words, if you look at the y-axis, look at one side, right? If you were to place a mirror along the y-axis, this piece here is the image of this on the mirror. Just like how you would stand in front of a mirror. You are on this side, when you look at the mirror, there's that ugly guy on the other side, which is not you. It's not you guys. It's just an image. Because what usually happens with that thing that is on the other side, if you raise your right hand side, it raises the left, which means it's not you, it's just something else. So just like when that thing happens, right, when you look, you place a mirror in front of this side. These are the y-axis, right? You place a mirror, you stand like this, and you look at this function on the mirror. It's supposed to have the other half on the other side. You getting it? Or if you were to cut the graph on the y-axis, this side should overlap on top of this side. If that is the case, the function will say it has even symmetry. You getting it? Exactly. Okay. Now, if you get this, let me give you another example. Suppose I'm giving you a modulus function. Modulus function and absolute value, one and the same thing, guys. You getting it? So, if let's say I am giving you f of x is equal to the absolute value of x, do you know how to plot this curve? Okay. You know that this is going to be x if x is positive or minus x if x is negative. You're getting it, right? So you have an x and you have a y. Now, if x is positive, our function is y is equal to x. How is the shape of y is equal to x? How does it look like? Just draw it somewhere on the air. It goes like this. It goes like this. Guys, is it going like this? Like this? Like this? Is it going like this, guys, or like this? Like that? Oh, okay. So it's supposed to go like this, right? But now, remember that this part is only for the positive x values. So the positive x values start there. So we're going to have that part. And then now when we're talking about the negative x values, if I have a negative x value, multiplying that with a negative, what do you get? A positive. So how will the graph look like? If I'm plugging in the negative, I plug in the negative and I multiply that negative by negative. Will I get something below the x's or above? Yes, so it's going to look like this. Now I'm asking you, does this curve have an even symmetry or not? It does, because if I were to cut here along the x-axis, this side will fall on top of the other side. Are you getting it up to this one? Yes. Now, this is, you can see that you can play around that function there, which is x squared plus a 1, and then you can check that. What does it mean now to have an odd symmetry? Anyone have an idea? We talked about the even, that it is, and it has one side is a reflection of the other side along the y-axis. So what about the odd symmetry? Yes?
What symmetry is when, if you put a line across the graph, it doesn't cut it into two equal parts. It's sort of like...
You like the cutting. You enjoy this cutting. Always want to cut something. Okay, fine. Let's hope you're not cutting people off. Because people like people to cut things. Sit your mom, I'll cut you off if you do this. Any other explanation or any other view? Yes, ma'am. The line y is equal to x cuts it in half. Okay, you have something interesting. Hyperbole. Were you raising the hand? Oh, okay. Yes. If you have the negative. Okay. What do you think about it? Okay. I'm going to give you a graph here. I want you to tell me, does it have odd symmetry or even symmetry? I want you to tell me, guys. It might happen that you do understand odd symmetry. It's just that it's me who's giving you an odd question. So it's the question that is odd that is actually giving you a problem or anxiety. If I give you y is equal to x, is that function does that function have an even symmetry? Let's start there. If I were to cut along the y-axis, will this side overlap on top of that? Not really. Remember that the line should fall on top of the line. You get it? Yes. But now you see, when you're cutting it, the other piece is there. So it doesn't have even symmetry. Get it? Yes. Now, does it have even symmetry? According to what you said, does it have odd symmetry? According to what you're saying. Okay. Here is the thing, guys. This is the simplest way to look at this thing. The other hard one. Let me start with the hard one. I want to confuse you a little bit so that in case when I'm giving you the simplest, you will forget it. If, let's say, I have this curve, remember that with even symmetry, right? If I give you 1/2, I mean I give you a half of the curve like this, or that, or whatever it looks like. All you need to do to get the other half, place a mirror, right? And then the image on this side will be the complete, will complete the graph to have both the two sides. Do you get what I mean? Or you can take this, make sure that this graph have more ink. There's more ink there. And then you place your ruler in the middle, and then you take this side and place it on top of that. That ink that it will leave there will be the completion of the whole curve. Do you get it? Do you get it? Yes.
What I'm getting here is that if it's sort of, you see the graph has like a horizontal line, so if both of them are on the top, then it's even. If one is at the top and the other is at the bottom, then it's uneven.
Thank you. Yes, that's what is happening. Both of them have to be up there, or both of them have to be down there, but also the shape have to be the same. Yes. Thank you for that. Now, when it comes to the odd, this is what is happening. If I give you 1/2, starting from the origin, right? Whether it's the half is this way, or that 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 way, doesn't matter. The first thing that you do, you place your mirror along the y-axis. You getting it? To get the other half. And then you get the reflection or the image of the other piece. Then after that has been done and you can see, okay, this is what is happening. You place the mirror again across the x-axis. And then the image that you will get will be your final answer. So you have two reflections. The first reflection is along the y-axis and the other one is yes. So for this one here, if let's say this function I gave you, I place a mirror along the y-axis, the image that I will get is gonna be of this kind for this piece here, for this piece. You getting it? And then when I'm placing the mirror along the x-axis, the image of this part is going to be this part. Are you getting it? So you have this two-step process of getting the other parts. That's how we define an odd. But the easiest of them all is if half of that function or the other piece, you can rotate it by 180 degrees to get the other part. It is odds. Are you getting it? So, if I take this piece here, can you see this piece? This piece, and I rotate it by 180 degrees, I will get this piece. That's what I mean. So this one is odd. Are you getting it? You look at one piece, let me say I'm looking at this piece here, this piece. If I rotate it by 180 degrees, is this 180 degrees? Is this 180 degrees? Is this 180 degrees? So here we have 180 degrees, that's what I'm saying. Is this 180 degrees? Yes, that's what you do. One piece, once you rotate it by 180 degrees, if you are getting the other piece, then it is odd symmetry. Are you getting it? Yes. Let me give you another example. Maybe you will say it. This odd symmetry and even symmetry is nice, and it has some marks. One thing that I've noticed is always comes out in the exam and the test. I don't know why the examiners like it, but either way, it always comes out. Now, I am saying to you, I have this function and I'm gonna draw it like this. Right, and then I want a different color here. My question to you is, I have only given you this piece of the curve, right? And the question is, draw the other piece so that this curve is that of a function that have even symmetry. Where will the other piece be? Even symmetry. Sorry? Which quadrant? Let's start there. I'm talking about even symmetry. Okay, odd symmetry? Okay, so you are saying that I should have something of this type. Now, is that a function? It is not a function, so of course we're not going to have that. We're talking about this even symmetry of functions and odd symmetry of functions. So where will the other half be if this function has even symmetry? Third. Those are saying third, raise your hand. You don't have to be shy, guys. Those are saying second, raise your hand. Yeah. Those who are like me who are confused. You confused me, guys. I don't know now even the answer. Those who are confused like me. Yeah. Now, when we are talking about even symmetry, all your focus should be along the y-axis. Are you getting it? Yes. When you place the mirror along the y-axis, where the image will it be? It will be on the second quadrant. So you're supposed to have this thing here for even symmetry. Copy it, please. I'm talking about even, not odd. Even. This is nice. Yeah, you can add a few things and then you get a heart. No, people like hearts. And also saw this social media thing, they're adding more hearts. They can see that people just start moving once there's a heart. Yeah. But in that case, I want to move on to something else, guys. Odd. Now, the question is, draw the other piece such that this function has odd symmetry. How do you go about it? Where is the other piece? It is third quadrant. So you want to rotate this thing by 180. So if you rotate it by 90 degrees, you're supposed to get something of this type, right? This is 90 degrees. Is that so? And then now, if this from here to here, that's 90 degrees. And then you rotate it again so that you complete the 180 degrees. So it's going to be something of this type. Is it so? Yes. So this piece, this is the final answer. This is the final half. Are you getting it up to this one? Yes. The rotation. Okay. What I'm saying is, first you had this nice function here. This piece. And then you want to rotate it by 180 degrees so that you get odd. Right. Now, if you are rotating this image by 90 degrees, you are going to the next quadrant. Then the image that you have is in the next quadrant. If you were in the fourth quadrant, the image should be in the first quadrant. If you were in the first quadrant, the image would be in the second quadrant. If you were in the third quadrant for 90 degrees, right? Getting it? So you draw that, just take it as it is. Just rotate it by 90 degrees. It should be on the second quadrant. And then again, you rotate it by another 90 degrees because 90 plus 90 is 108. It should be on the third. You getting it? This is what you just do, guys. Just rotate it like this. It's not hard. Rotate it like a clock. Are you getting it? You happy? Yeah, just rotate it like that. Now, mathematically, how is this thing supposed to be? Mathematically. So, if let's say I give you a function f of x equal to something, then f of minus x is supposed to be minus f of x. Are you getting it? So if I give you a function to test if this is odd, this has odd symmetry, all you need to do, just plug in minus x in the function. And then if the output gives you minus f of x, then it has odd symmetry. For instance, let me say you have f of x is equal to x. Okay, let me use x cubed, for instance. X cubed. Now, does this function have odd symmetry or even symmetry? We don't know. We have to check it out. Right. Now, in order for us to check it out, you plug in minus x. And then if I'm plugging in minus x, there I will have minus x cubed. And this is the same as minus x times minus x times minus x, right? Minus x times minus x plus x squared times minus x. So it's going to be minus x cubed. You know this stuff. But if you look, we have this minus here, and you still have x cubed. X cubed is the same as the original function. So you have minus f of x. Can you see? So if you have something of this type, then you know that you have odd symmetry. Are you getting it? This is not that hard, guys. It's not that hard. Just copy it out. These are the marks that are just sitting there waiting for you. You pass this damn thing and you never do it again. Think about it. Yes? What I am saying that when you are dealing with the even symmetry, just focus on reflection along the y-axis. You getting it? And then when you are dealing with odd symmetry, rotation by 180. The reason I was talking about 90 is 90 plus 90. I just wanted you to see the picture of getting to 180. That's what I said. Are you happy? Okay. Any other questions so far? Or do you still have another question? You're sorted. Okay. I will be sorted next week. So we are there now. We talked about this, and these are also some of, and we looked at into this. This is other half. And this one here, you can see that this is what I was talking about. First, you do the rotation by 90 degrees, and then from 90 degrees to 180 degrees. That's what this picture is all about. If it's confusing you, sorry, but it is what it's supposed to be. Now, I'm giving you a curve. I'm trying to be slow as possible here. Yes, sir. And then another reflection again along the x-axis. So you first have your reflection, you get the other piece, and then you get another one. Are you happy? There are two reflections when it comes to odd, but even this one. That is why I just said focus on rotating that damn thing. Okay. How do we say a function is increasing or decreasing? What is the meaning of a function increasing or decreasing? Now, when you are dealing with a function, I need to be fast here as much as I can. When you are having a function, we'll do this thing again with the derivative and other things. I just want to give you a picture. You getting it? When I am saying to you, a function is increasing in this interval. In other words, if I pick two input values in the x-axis and then I go up to the actual curve, whenever I decide to pick 2 points in between, one on the left and the one on the right, I will always see an increase. Then I say, okay, this is increasing. You getting it? For instance, I'm drawing this curve here, and this is my curve, right? I'm saying this is my curve, right? Let me do this. Is this function increasing or decreasing? Is it decreasing? Is it increasing? It's decreasing. Listen, guys, what I'm saying, this function here, if I were to pick a value here, let me just call A, and I pick another value there, I call it B. I will say this function is increasing in this interval. If whenever I pick 2 points in between, and I go, oh, what's going on here? Sorry. I pick 2 points there, and I shoot them up. This point and that point, when I'm drawing a line in between, I will always find out that the slope is positive. Are you getting it? That's what I mean. And then if there exist 2 points within the interval, such that if I pick those 2 points, I'm not getting a positive slope, then it's not increasing, and it's also not decreasing, right? So if, let's say, my B is no longer here, let's say my B is somewhere here, is that function increasing at that interval? Not really, because I can pick a point here and say this is my point. What's this thing is doing today? I can pick a point there and then pick another point there. Is the slope increasing between the two if I draw a line? It is decreasing, so we cannot say it is increasing at that point. You're getting it? That's the main thing I wanted to talk about this. But one thing that is more important, how many minutes do we have? 1. Okay, fine. And this is your homework. Take it as a homework. I'm going to upload this. Take it as a homework. I want you to determine if it's this having. Just take a snapshot. Can you borrow me 2 minutes of your time? There's something I wanted to tell you, which is more important than anything we've done so far, and more important than anything that we are going to do in the future. Because this is what you will actually be doing in your field. Now, if let's say you have a data of this type, how can you find the function out of that thing? How can you find, because when you have data, you have to analyze it. You're going to go to a lab, some of you will go to the lab, correct some data. How can you find that function that is correctly representing that? Yes.
So y and x-axis is the domain and radius.
Yes. Thank you. So you have 2 things, so you're going to have x and y. What I wanted to tell you here, when you get some free time, do this, because you will have a project later in the course. I will give you data of this type. I want you to plot it. I want you to find the function. On top of that, I want you to find the derivative of it. And then fourthly, I want you to find the integration, like to integrate it. Or to find the antiderivative or the area under the curve. Those are the things that I will ask from you. So what I want you to do, whether you have a laptop or you don't, you can go to lab. You just type GeoGebra Classic there on your web browser or internet engine. Then once you do that, you will choose the first one, which is GeoGebra Classic. It's always going to be the first. GeoGebra Classic. You're not saying anything? Sorry. Can you see now? No. You're not saying anything? Oh, I think you want to leave. That's not going to happen. Now, are you saying something? You are lying. I know. Now, I'm saying, yes. Type GeoGebra Classic, and then you choose the first one, And then after you have chose the first one, you're supposed to see something of this type. You're supposed to see something like this, right? And then you go to the three dots that are up there. Once you click there, actually you are just looking for the Excel in that thing, the spreadsheet. That's what you are looking for. And then once you get there, you will see there are three dots there. And then you click on the three dots, and then you go to the spreadsheet. And then you will start to see that when you click on the spreadsheet. You can move this thing on the left so that you're left with the spreadsheet. These notes will be uploaded on Unreal Connected. You don't have to worry about the steps. I just want you to see. And then once you do that, you type in the numbers, highlight them. After highlighting them, you will see something up there. But this is the most important thing, this part here. That's where you end up choosing. Are you going to choose a polynomial, quadratic, or hyperbola, or what is it? Exponential, logarithmic function, or linear? Yes. You choose there. And then when you are choosing, it is the one that will tell you whether the function is representing the points correctly or it is missing it somewhere. And then once you do that, it will also be telling you the function down there, the function that you are looking for. So now, when you are doing analysis of your practicals somewhere in your department, this is what we usually expecting. If possible, get the function. When is it increasing? When is it decreasing? And when is it has a maximum value? Which means that if you added a catalyst, now the catalyst is starting to die down. You get what I mean? So that's what we expect. If you don't do this, don't be surprised in your practicals when you are getting less than 50%. It's not personal. You haven't done anything. You just have some bunch of numbers. You do not analyze them. Thank you. Try and do this when you have time.